everyone, in this video I'll show you a simple but classic encryption technique called the Caesar cipher. It's one of the oldest way to hide a message, and surprisingly, it still teaches us the basic of cybersecurity today. The Caesar cipher works by shifting letters in the alphabet. For example, if we use a shift of 3, the letters A, B, and C becomes D, E, and F respectively. This way, a simple message turns into something unreadable unless you know the secret shift number. Let me show you how it works using the website decode.fr. I'll type in the message, "Cryptography is fun," and use a shift key of 3. Then I will click the encrypted button to show the encrypted message. As you can see in the results, there are 2 encrypted messages. We will only focus on the first one and ignore the second one. So how does it work? We use shift 3 of key means the first 3 alphabets will move. So letter A will shift to the last position, followed by letter B, and then letter C. So the first 3 alphabets now will become D, E, B, and the last 3 will be A, B, C. First, take the first letter of the plaintext and look it up in the plaintext row of the Caesar cipher table. Then, find the corresponding letter in the ciphertext row. So the first letter will be C, and its corresponding letter will be F. For the second letter will be R, its corresponding letter will be U. And the third letter we will take Y, and its corresponding letter will be B. Repeat this process for each letter of the plaintext to get the full encrypted message. So how will we decrypt it back? To decrypt the message, you just reverse the process. You can directly refer the table. So the first encrypted letter is F, its corresponding letter will be C, and the second encrypted letter is U, so its corresponding letter will be R. The third encrypted letter is B, its corresponding letter will be Y. Repeat this process until you get the full plaintext. Now let's go back to the decode.fr website and paste the encrypted message into the Caesar cipher decoder to get our plaintext back. As you can see at the result, it shows our original plaintext. So why it is important in cybersecurity? The Caesar cipher is a basic form of substitution encryption. While it's very easy to break today, it shows how encryption works by hiding information in plain sight. While the Caesar cipher itself is no longer secure, it laid the foundation for modern encryption techniques. It's a basic form of encryption that introduces the concept of shifting or substituting letters in cryptography. It's an essential building block in cryptography and a great introduction to the world of encryption.
Hi everyone, let's dive into a fascinating concept used in cybersecurity and data verification, hashing. We will explore how it works using SHA-256, demonstrate the avalanche effect, and understand why hashing is critical for data integrity. First of all, what is hashing? Hashing is a process that converts any input, like a message or file, into a fixed length string of characters. This output is called a hash value or digest. It's like a digital fingerprint, unique to the data. Even the slightest change in input creates a completely different hash. Let's do a live demo. Let's put hello world. See the output. Now watch what happens when I change just one letter, like removing the exclamation mark. The hash changes completely. This is called the avalanche effect. Even a tiny change causes a dramatic change in the hash output. See, it's completely different. So why does this matter? Hashing is crucial in 2 key areas. Number 1, data integrity. It allows us to verify whether a file has been tampered with. You can check the hash of file to see if it matches the original. Number 2, password security. When you create a password, websites don't store the raw password. They store its hash. This way, even if a database is hacked, the real passwords are not exposed. To summarize, hashing creates a unique, irreversible fingerprint of data. The avalanche effect ensures even the smallest change to data are detectable. Hashing plays a key role in cybersecurity, data verification, and protecting sensitive information.
Okay, now we move on to general understanding of MAC and showing some live demonstration. So what is MAC? MAC or Message Authentication Code is used to authenticate the origin and nature of a message. It is somewhat similar to digital signature with the exception of being more efficient and less complex to implement. Hash MAC is a category of MAC that uses a hash function and a secret key. It achieves authentication and verify that the data is correct and authentic with a shared secret key. So in this case, we have the input London Bridge is falling down with the key Alice and hashing function SHA-256. You can see the garbled output here, AE5BD. So how do we verify it? Okay, to verify hash MAC, so here we have the original plain text, the original input, original key, and the original output. You can see the original output is AE5BD. So any changes were made. For example, if I were to change the plain text, bridge is falling. Okay, the output will be completely different despite being the same fixed length text. It will have a completely different change. It will have a completely different output. If I were to fix it back, yes, comparing it, yes, it is still the same input. While changing the we'll also change the output. Okay. Okay, now we know that. So MAC helps in authentication by using a secret key, not only to the sender and receiver to create a unique fixed length code that verifies the message authenticity and integrity. Well, MAC ensures integrity uh, because any changes to the original plain text will produce a completely different MAC value.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Akimi, and now I will be presenting task 4 digital signature. Okay, so first step is PGP key generation. So at the identity will enter my name, and paraphrase is the key. So then enter the generate key pair. Okay, so that is the output. Then we move on to PGP encryption and decryption. So we put the message that we want to encrypt, and the encrypted message will be the output. Okay, so next is the how the signature is generated and verified. Signature generation. A hash of the message is created using a cryptographic algorithm. This hash is then encrypted using the sender's private key. The result is appended to the original message as a digital signature. Then the verification process. The recipient uses the sender's public key to decrypt the signature. Then the recipient computes the hash of the received message. If the compute hash matches the decrypted hash, the signature is valid. Okay, so next we move on to how digital signature ensures security properties. Okay, first is authenticity. The digital signature confirms the identity of the sender. It is since only their private key could have created it. Okay, next is integrity. If even a single character of the message changes, the signature becomes invalid. This ensures that the message has not been altered. Lastly is non-repudiation. The sender cannot deny sending the message later because no one else has access to their private key. Okay, that's all from me. Thank you.
Hello guys, my name is Ravi Shankaran and I'll basically bring you guys through a steganography tool, its usage and how important it is in cryptography and in cybersecurity fields. I choose Tag Online for our demo today as its interface is very easy to navigate through and it works well. So before we jump right into the demo, what is steganography, you may ask? Steganography is a technique used to hide secret information inside normal files like pictures, audios, or even videos. The idea is that no one should even know there's a hidden message in the file. So unlike encryption, which we studied in our class previously, that makes a message unreadable, steganography keeps the message completely hidden so it looks like just a regular file. So this is the steganography tool that we'll be using today, and it's called Stag Online. Basically, what we'll be doing today is that we'll be encoding a normal JPEG file. In our demo, Bingus will be our normal JPEG file. This is Bingus, by the way, and we'll be encoding him with a secret message and then try to decode him back to see if the secret message can be read back. And in our tool, basically what we'll be doing is, first of all, we'll be choosing a file. Bingus is our desired file to be encoded, and the tool requires you to give a password. And in this case, let's say 1234 is our password. This password is very important when we try to decode the encoded file back, so that we can get the secret message instead of getting an error or something else. So basically will be our password. We'll be using this later on when we try to decode the encrypted file. So 1234 will be our password, and in this section we'll be putting in the secret message that we want to encode into our file, and this will be our secret message. So Bingus is a spy. All right, so basically we'll be submitting this and we'll get a new encoded file named Bingus, and now let's try to decode that file. So basically in this tool actually helps us with encoding and decoding, so we'll be using the same file to decode it back. Now we gotta choose the encoded file since we are decoding. So where was it again? So okay, all right, this is the encoded Bingus file. So we gotta put in the password we used previously, and let's see, and we'll be getting the same secret message that we used previously, which we encoded into our file called Bingus. So the cat known as Bingus is a spy. So overall, steganography is a powerful tool for secret communication. It helps journalists and activists share info safely, hide military or mission critical data, digital watermark to protect copyrights, but it can also be misused to hide malware or stolen data, so detecting it is important in cybersecurity. In the right hands, it protects privacy, but in the wrong hands, it can be dangerous. Thank you.